Okay. So it's my pleasure to introduce the last talk session of the day about performance in R. And we start with Suzan Baert, who already did a great job this morning with the Tidyverse workshop, despite a broken arm. So welcome, Suzan, and it's up to you.
Good. Thank you, everyone. It's a complete pleasure to be here today in Paris. I don't live too far away, and still this is my first time in Paris, so I should really slap myself or something, because it's only about an hour on the train, so I will spend some time tomorrow, and hopefully I'll come back very soon. I work as officially it's business intelligence. In reality, most of my work is analytics work, so there's a lot of data manipulation involved, there's a lot of reporting involved as well. And so far, I did change job not too long ago. Before that time, I was working in many other analytics languages, but R was one of them. But the data sets that I had usually were quite reasonable in size. They were even small, if you would think about it. That all changed in October when I started a project at a client that is one of the biggest Belgian banks. And for some reasons, good and bad, I was not connected to the databases. I got data extracts all the time. And so my kind of data sets, sources that I've been working with since October are huge amounts of CSVs that are pretty large in size, not big data terabytes, but nonetheless, for this to have it on your local PC, the PC I got is also not one of the best PCs, has been quite a challenge. And the very first week that I was working there, one of the things that I have to do is this is about comparing of different databases. They have an old database from a different set of bank branches, and we need to do a lot of analysis on that data, compare it versus the new databases. So not only do I have a lot of CSVs, I have to merge all of these CSVs, and I have to cross-compare them. So my very first week there was not very pleasant. Day one, that stop sign in R became all too much of a familiar sight. The error message, cannot allocate a vector, drove me absolutely insane, because it also meant that I could not just run a script, go away for an hour and come back, because I would just see all kinds of errors. So I seriously had to rethink the way I was programming in R, and I was using it. So I did a lot of research looking at what other people are doing. And one of the things that would drive me a little bit insane is, I'm just quickly gonna do something weird, because I don't have I'm used to seeing what the next slide is gonna be in the timer, and I'm not seeing it, so I hope this is not gonna not work now. So much better. So with all the issues that I had, one of the things that I really started to wonder is, what is speed? Because the moment you start reading what people say on Twitter or in blog posts, there are some fabulous blog posts out there, but there's a lot of blog posts that talk about one thing only. They only talk about CPU processing time, which was part of my issue, so that's good. And they equated the CPU processing time and the issues they had to the speed of a certain function and the speed of a certain package, which is very fair. It's an issue. I'm sure everyone, I make some packages, but I don't have a lot of big packages. Those of you who do know speed is very important. But speed is a lot bigger than this. And one of the things that the moment I started talking about the fact that I have an issue, everyone started telling me that I had to use very fancy tools. I had to go to parallel processing. I had to go to Spark. I had to go to God knows what. And that can help people. And I'm certainly not here to say that you don't need parallel processing packages. I'm not here to do any of the sort. But what I do want to talk about is that there's an awful lot that you can do to speed up your code that does not require you to go very advanced. That requires many other things. And I'm not the only person who's had this experience. I'll share some links later of people that had very similar circumstances than I had. So when I think about speed, I think speed is a combination of three things. CPU processing is there. It is important, and the bigger computer you have and the more RAM you have, the easier your life will be. But it's not the only thing. There is a second part that I've called here brain processing time. It's everything that happens outside of your PC. You'd be surprised how much time you spend on the first one. And the last one, which is context. And one of the first, I'm going to start with context. I do want to run through some of that. The very first important context is, what is your experience? What is your experience in the thing that you're doing with? Because you might have been coding for 10 years in R but never done spatial. We had a lot of talks about spatial. The moment you're going to go to spatial analysis, your brain processing time is probably going to be much more impactful than the CPU processing time. We had the workshop for beginners this morning. You know, a lot of the commands, if you're working with dplyr for so long, that just come natural to you. In the beginning, they don't come natural, and you do have to think about it. So CPU processing time is important, but probably not as important for everyone at every stage that there is. There is something else. The team that you're working with, if you are working alone on your island and you never have to share any of your code and you never have to collaborate on code, maybe you don't have to care about it. But if you work in teams, I had to send a lot of scripts to other people. I can tell you, in some of them, I was very ashamed to send them. I wish I had a day to clean them up before I sent them, but I didn't. But still, it's something to take into account. How often is your code run? A lot of the scripts that we make in R are run once, twice, 3 times, maybe once a month. Okay, we have shiny apps. We have some people have packages that are so popular that the functions are being run a couple of times every minute probably, but that's not the case for all our scripts. And if you compare R to some of the other programming languages, our scripts don't get run all that often. So in some cases, is CPU the most important? I'm not sure. What is the size? What is the type of your data set? What kind of work are you doing? All the people that immediately told me you have to go to parallel processing did not ask me what I was doing. Parallel processing was not going to help me because I was not doing anything iteratively. I was doing very sequential exploratory work. How am I going to divide it up to different clusters? So what you're doing, all this context is important. There are also some more temporary contexts that are important. If you happen to break your hand, right now for me, neither CPU nor brain processing time is most important. I'm concerned about the number of typing. I'm especially concerned about anything that I need 2 hands for. Control Enter, it's not that easy. Copy pasting, not that easy. So these things change, and I think we do have to keep some of that in mind when we're talking speed in general. But of course, the 2 things that I want to talk the most about are the first 2. And I'm going to start with the first because I think it's the one that gets a lot more attention within R, within the programming world in general, but probably still not as much as I would like it to have. And then the second part of the talk will talk more about CPU processing time. So the brain. The brain is very involved when you do code. First of all, when you originally write the code, when you're revisiting code that you wrote afterwards, it's not always a pretty sight. When you get someone else's code on top of trying to figure out what they were doing, you also are dealing with someone else's logic. So sometimes this is more how I feel. I'm sure other people feel that way about my script. This is not very particular. But brain processing time should not be exaggerated. I've read some posts where people were talking about, to them, very big differences that were talking fractions of seconds. Now, again, context is important. If that code is going to go in a package that is run very often, if it's going in a Shiny app or in production that's run very often, then that fraction of a second might matter if it's part of a long script. But in many of the cases, let's be honest, execution, that fraction of a second, compare that to the time that it took you to write the code. I timed myself before I had this, when I still had 2 hands. A lot of the code, the small lines, I'm not talking entire pipelines, easily took me 15 seconds to write a small line. If I time myself doing a whole pipeline, it's a lot longer. And this never happens, because before you even start typing, how am I going to do this? Which might be very short if it's something easy that you've done a number of times before. It can be a couple of hours that you just think, how I want to do that, how do I get there? What do I need to do that? And that never happens either. Well, it happens, but not always, because what sometimes happens is errors. Then you get to fix some silly mistake if you're lucky. If you're not so lucky, you spend eternity on Stack Overflow. But all that versus then I can speed up my code with a fraction of a second, which makes me sometimes want to make sure that people see the whole as well. So when you're talking writing code, okay, there's the time to think, to strategize, the time to type, the time to learn, time to debug, it's all part of it. And one of the things that really helps with this, and once I started learning R a couple of years ago, and I gave up after 3 weeks. And then I restarted learning it and actually using it a couple of years later. And there is a huge difference in the R packages that are out there now versus before. And I'm sure you've all noticed that as well. Trying to decrease that brain processing time is a journey that nearly every maintainer is on, and they all inspire each other to do even better. This is one of my examples. I love the string R package. I think it is so easy on my brain. The moment I decide what I want to do, I nearly always have the function I need. The syntax is always the same. I do not like using the base R functions. I did time them. They are tiny bit faster, but it takes me longer to figure this out than the first one. Now that might be personal. There are people who are used of the other, and I'm not here, I don't want to say at any case in this talk what you should do, but just decreasing the brain power is very important. And R is not the only language where that is happening. A very long time ago, I learned some Java. I don't know anything about Java anymore. But if I wanted to restart Java, I do not want to learn Java 7 or before. I would love to do Java 8 then. Because even without knowing Java, if you try to read the first one with the ifs and the fors, it will take you a little bit longer to try and figure out what is going on. If you look at the second one, you have a list, I'm filtering the list on a date, I'm doing distinct, and I'm collecting. You quite fast might get at least a clue of what you're trying to do, which the first one is not doing. So it's not just R moving that way, there's a lot of languages that are trying to just make it so much easier to read code, to learn it, and to actually use it. What typically can be a bit harder on the brain is revisiting code. And I love this cartoon. We don't have code reviews, I don't think there's a huge practice of doing code reviews within the R community. I know some people who do it. But I think of this as me just reading code that I wrote earlier or someone else. And I think there's a lot that we can do. And I've read a couple of books that are not focused on our community. It's a couple of Java books, for instance, on how we can do this. And I have to say that once I started to pay a bit more attention, I did start to change the way I write my scripts, and it gets a lot easier. And so the general goal should always be to kind of decrease the cognitive load that is required to read. Well, because while you're typing it the first time, you are in a certain mindset, you know what you're doing, you know the 5 things you just tried that failed, you know exactly where you're going, but 2 months after you don't know, or someone else doesn't know the logic that you're in. And so some of the things that happen, we talked about the first one, syntax. If the code syntax itself is very readable, that's going to make your life better. I have started to do the habit of explicitly adding my argument names. This is code I use very often because I share my output files to a couple of business experts who don't know any analytics language, and then they send me stuff back in Excel. And so I always lose my leading zeros in the ID codes. They have to be 10 long and always lose the zeros. So I'm constantly adding zeros. I made a function that is even faster now. But this is perfectly fine. This is much faster to read what I'm doing because the argument names are there. Now, it takes me more time to code, but if this is a script that I know I'm going to revisit, that I'm going to send to someone else, much more than I did before, I'm actually spelling out the argument names. So it takes me more time to write, goes faster afterwards. Another one that absolutely drives me insane, because I have a colleague who refuses to do this. So we're working on the very same project. He might not like the fact that I'm saying this, but I've pointed it out enough. And so first of all, we bring in a lot of data sets, and then we filter and subset it like crazy to make it manageable. and he calls every single one of his data sets is called data 1, data 2, data 3b, or test 1, test 2, test 5b. And the tests stay that way, because I sometimes call them tests as well, but then usually it is a test, and afterwards it gets another name. And so he thinks it's fine, because when he's coding, he knows exactly what test 5b is and data 2. But then when I go to ask him a question, first of all, if he sends it to me, I have no clue. And 2, I have noticed every single time that I go and ask a question, he has to scroll up like crazy to figure out which one he needs to do. Because at the very end, some of his scripts look like these. These are anti-joins, they're in data table. So he wants to find out who is in data that is not in data 2. This is what I recalled it afterwards. Now, you don't know my project. You might not know exactly what I'm saying with left after wave 1. But if you do know a little bit, I very much prefer number 2 versus number 1. So I am even trying to challenge myself now that even if I only have one data set, I'm not calling it data anymore. Other things, use smart comments, use indentation and line wrapping. When I talk about meaningful names, I also mean your function names. I mean about just about anything that makes it so much easier afterwards to just kind of read through your code versus what it otherwise might be. That's brain processing. So there are a couple of things. There's a lot of books about there. One of the very good ones is Clean Code. It's a Java book, but a lot of the tips that are coming there, honestly, they're the same in whatever you're coding. So this is if you're interested in this, there's a lot of material out there. Now, I don't want to forget the CPU processing time, because that's the part that I struggled with, right? The part where my memory allocations were going wrong, where I was watching a stop sign in R was not because of my brain processing. There's a lot of stop signs there occasionally as well, but it wasn't there the first week. So what is the fastest solution? And of course, there are differences in functions. I will show you some of the stuff that I've been studying for myself. But one that we should not forget is the strategy that you use behind your code. And I think that's one that many people don't think about often enough. And I didn't think about it well enough in October, because I never had speed issues. And then, of course, there are some specialized tools. So how do you find out what is fastest? There are a couple of ways. I think one of the easiest ones is to benchmark. And there is a package out there, it's called Micro Benchmark. That is very easy. If you have 3 or 4 options to get to a certain code, you just insert them. So you open a micro benchmark, you put all the options that you have, and you say how many times you want it to run. I would not advise you to start with 200 times. Start with 5, see how long that takes, because your computer might be busy for 3 days otherwise. But of course, if you want to be very sure, and depending on what it is, you should run a lot of benchmarks. What this will do is this is going to run every single function 200 times, and it's going to time how long it took. It's a simple explanation. As of October, I started to do that a lot. And one of the things, you will find a lot of blog posts out there with micro benchmarks. If you're really interested, I would say do them on your own data set. Because that's one of the things that you see happening a lot in these blog posts, is they make a data set with random numbers between 1 and 1,000 for 10 million times. But that data set looks very different than yours. It might not have the text variables that you have. It might not have the structure that you have. So if you want to do it, take a data set that you're struggling with and do it on that one. Now, I could not show you anything today on my bank data sets. So I picked another one. Seattle, the city in the US, has a very large open data platform, and one of the data that they're showing very freely is library data. So these are all the checkouts that are being done in the library from, I think they started in 2005, is the first year that they did it, and last month was on there as well. So what you get, I liked it because one, it was huge. The data set itself, I think, was about 7 gigabytes. So huge in CSV world, not huge in big data world. And it had a lot of different variables in there. There are some that just have 2-digit numbers, but for instance, the title was a very long text field, so he had quite a lot of things that I could play with. And one of the things I wanted to compare is in what degree does the size of the data set matter? and as of when does it matter which functions that you're choosing. So I took the data set, I made 3 subsets of it, one that was about 600 megabytes on disk, 2.5 gig and 5 gig, to just see what is going on. And so I'm comparing packages. Now, I want to say up front that I'm Switzerland. I am not a designer or a maintainer of packages. I am very opportunistic because I love to just take the blood, sweat, and tears of other people and I use it, and sometimes I judge it, but I judge it with love. So whatever I'm going to say, I know I've always been surprised, but I have seen that sometimes there's a bit of a, are you this camp or that camp? I'm no one's camp. I just use the packages that are out there. And for today, before I get comments, because I know there's going to be a lot of statisticians in the room, I did not do a lot of repetitions on this. 2, because first I had already done that on the big data, and 2, I wanted to show different data sets and different functions rather than running everything 200 times. So most of the things I'm going to show you, I ran only 50 times, sometimes even less than that if it took an awful lot. So I know that's not perfect. Please don't shoot me. One that is, before I go there, what I'm going to show today is I tried a couple more packages, but for today I focused it on the 2 most known data manipulation packages. So there is dplyr and there is data table, and in many cases I added base R to it as well, just to see what was going on. And so I'm going to start with the ones that are very well known, I think. If you browse the internet, one of the things that people see typically very big differences on is importing and exporting data. So I'm going to start with importing. So just to show you what you will see, you have the 3 different dataset sizes. That is the time in seconds. Now pay attention to the y-axis, because sometimes this one goes up to 200 and sometimes the y-axis stops at 0.5 seconds. So it's a little bit tricky. And then I put some of the syntax of what I've done. Importing CSVs is fairly well known. Base R is not very speedy. Read R is a lot faster, but data table is even faster. And so the numbers, this is about 40 seconds. With read R, it would take me about 2.5 minutes. So that is quite a big difference. And so that's one of the very first things I've started to do. I'm importing my CSVs with read data table now. Of course, if your CSVs are very small, it's not going to matter too much. But for my 6 gigs and 8 gigs databases, this really made a difference. Very similarly, I'm constantly writing my data sets so that the experts can open them in Excel and have a look at what I'm doing. Exporting is also fairly well known. Base R, I gave up even trying to have him to write it 10 times, so that's not even 10 times there. Then you have read R, and then you have data table, which is a lot faster. So these are 2 examples that I think are fairly well known, that reading and exporting, if you're doing CSVs, data table is faster. And what I do want to add is the brain processing time is fairly similar. Okay, fwrite, the very first time you might not know what it is. Write underscore CSV is a lot more straightforward. You're writing the CSV. But it's not very difficult to do the data set, the data table. I also tried it with a lot of extra arguments. I very often want to read the min-all-less character because I don't want him to treat my IDs like numbers and dates like God knows what. It doesn't seem to matter too much, but if you want to know for sure, you should just micro-benchmark yourself on some of them and you will see what's going on. A second one that is quite well known is counting. Now this one, if you really want to know, you just have a look in the right upper corner of your RStudio and it'll tell you much faster than running this. But if you really wanted to do it code-wise, it doesn't even matter how big your data set is. The n row of base R is actually the fastest in this case. Now, if you look at the Y here, we're talking fractions of seconds here. That even with my 5 gig, I mean, I'm not really caring too much about it. So you just pick the one that first pops in your brain rather than really going for the super option. Now, if you want to count per group, that's where it gets more interesting. base R, there's a couple of ways. I chose the table and sorting, which I think is already brain processing-wise not exactly my favorite option. The dplyr option with group by and count by is brain processing-wise, I think, the fastest. Everyone who reads that knows what you're doing. It's not the fastest in CPU time, so on my 5 gig that took about 2 seconds. I can go to a quarter of a second if I use the data table syntax, which is still, I think, once you know it a little bit, of course, skill is important. If no one ever teaches you how to do it, then you might not be able to read it. But once you do, .n stands for n for counting, and then in by you put the rest. It's fairly doable. Now, before you think that everything in counting is faster in data table, this is one I have to do very often. This is counting unique IDs. So I'm counting the unique client IDs because they might have multiple lines, multiple accounts, anything like that. I was very surprised about this because it doesn't matter. And I've run this one, I think, 20 times because I know there's only 50 buckets on there. It doesn't matter. You pick whatever one you want. So this thing that is counting is always faster in data table and you always win 10 times. It's also not strictly true. Last one that is very well known is filtering. So I'm filtering everything here for books that are written by James Corey. So that's the Expanse series that I snuck in here. dplyr has the easiest syntax by far. Data table, I think that's still pretty simple. It's also a lot faster. You go from about 35.35 seconds to close to 0. So there's a lot of time that you can gain if you're working with these 5 gigabyte sets. Again, a lot of us are probably on this spectrum. So you could do that. And if you're still fairly new to R, don't confuse yourself with using 2 packages to each other. Just stick to the one that is the easiest on your brain. But once you're more experienced, you can play a bit more. Now, adding variables. This to me was a surprise, to be honest. I didn't know that base R was so bad in adding very simple columns. I gave up trying to do it on the other 2 databases because it took so long. I don't know why. If anyone knows under the hood why base R is being so slow in this, I would love to find out. But for the 2 other ones, it doesn't matter. And then it comes down to preference. I personally do not like the updating by reference. So for those who don't know what that is, in data table, if you add a column like that, it is added to your base table. In tidyverse, it's going to be temporarily added unless you decide to save it as checkout. Data table just does it. They explain that that's why it's faster. It just does not, in many cases, doesn't sit right with me because I might be trying something and then it's added and then I have to reread or copy databases anyway. That's a personal preference. I know many people who love the fact that it's doing that, but on mutating, it doesn't matter. If I want to add some more advanced variables with some more advanced logic, I use a lot of case whens in mutate. And I've searched for it in data table, and I've read a lot of Stack Overflow answers of things that kind of look like case whens, but are, in all honesty, very hard to read. It goes back to basic math, but you're doing math with variables. I mean, it just does not sit right with me. So I didn't even try to do the benchmark here. When I'm trying to do something much more complicated, like mutating, like the case whens that I want to do, to me, there's only one option that is somewhat kind to my brain and to anyone who's going to read my code afterwards, and that is to go this way. Now, so far, I've focused mainly on single functions. They're not actually single functions. In some of these, a lot went through. And I did a lot more than what I'm showing here, but I didn't want to show the hundreds of benchmarks I did in real life on my data, nor all the ones that I did on the checkouts. But I do want to show a couple of chains. Well, I think I have only one. One chain. Both of the packages allow you to do multiple manipulations after each other. I am not going to talk for 2 seconds while you can try to figure out what I'm doing. And the data table is normally on one line, but that didn't fit on the slide. Some people got there already or not? Which one is the easiest to read? So what I am doing for those, so the data comes in the number of checkouts by month. I want to find out for every year how many for every year and every title, how many checkouts there were. And then I want to find out by year which one was the book that was checked out the most. So I want to get a list that says in 2018, this was the book with the most checkouts, 2017, which one was it? This is no surprise to all of you who know these packages, where the tidyverse does shine. It is a lot easier to read. Yes, it is slower, but I'm not doing these chains that awful lot. And if I'm choosing, I much rather wait for half a minute than afterwards, possibly having to go back here. I also have not figured out, if someone does know that, please tell me, but how you can kind of break this up in lines. In R, this is one gigantic line. Something that I don't really like. Now, this is a tweet that I saw, and I deleted the person who said it, because I'm gonna comment on it, and I didn't want to do that to the person with their name here without knowing on it. It's just one example, because I've seen this in many places, and that's why I started with the watch out of I am Switzerland, is there seem to be so many people who either you use the tidyverse or you use data table, and I don't get that. So he, at the very end, he says, I don't want to use it because I will lose the flexibility. You know, just be opportunistic, just use anything that you might need in your toolkit, just pick it up and use it. So what do I do, for instance, at the bank right now? I use both of the tables. So I did a lot of benchmarks to try and figure out what is fastest when I'm doing what. You don't have to do what I do, obviously, but I just want to mention where I got to. I use data table for import and for export. I use it for counting and for filtering, because that's where I see the biggest things. I use the tidyverse for nearly all my mutations, especially my case whens. All the more special transformations, I use it. I do most of my mutates just because I don't like the updating by reference, but that's very personal. I love string R and lubridate. I don't have to think about those functions at all. They come by itself. And joins, I pick whatever one comes first in my mind. I didn't show a lot of joins because I had a bit of time pressure on getting all the benchmarks to run. Joins, there is not one package that is always faster than the other one. It depends on the dataset size. It depends very much on the type of join that you're doing. So it's partially also why I didn't want to show it, because it's not very consistent. Now, back to the person who said this. Well, there seems to be some belief that you can't blend the two, which I find even funnier, because you most definitely can. First of all, so filtering is faster in data table, so I'm using it. But most of my filters are full with tidyverse functions. So here I'm using a filter from a data table, but I'm using a string R function inside it. So you can blend the two, of course. Can you chain and pipe the two of them? Now I'm going to show some things that I don't necessarily advise. It's only to make a point. But you can. The easiest one is to go from data table to tidyverse. Is you can start with a data table syntax. This is filtering on the material type book. And then you could pipe it straight through and do a mutate. I did a count here. You can do whatever you want, but that's the easiest. You can start with data table and flush it right through tidyverse. The opposite works as well, but is slightly less straightforward, I would say. And it has to do with the import that both of those packages expect. Most of the tidyverse packages are not very picky in what you give them. Whether that comes as a data table or a data frame or, what did I not say yet, a table, it doesn't care whether it already is. It's going to take it in, it's going to do its magic, it's going to give you a table back. Data table is pickier. It wants something to already be a data table. So if you, I forgot what the error is now, but it was my best friend for a couple of weeks after the cannot allocate into memory. If you did a case when, and then you're trying to go back to data table, it's going to complain about arguments that it doesn't know, because it's no longer a data table. So if you want to blend the two, you have to. So what I'm doing here is I'm starting with my checkouts data. I'm doing a mutate on it, and then I'm piping it through, but I have to pause here to make it a data table again. You can use satDT, you can use as.data.table if you want to, and then you can continue. Now, especially on the last one, it's not one I advise. It's possible, it's technically possible to do it. It's not something I would actually do because I don't think it reads very nicely. So what I would typically do after some of these mutates is I just save it as a new data set. So this is more something that I typically might do. I do all my mutate magic. I always have the habit now of ending every single pipeline with satDT, because then at least I'm avoiding the error that data table is going to give me afterwards, and then I might use some counts with data table after that. So you can perfectly blend the two. I didn't even show the most horrible one. Maybe I should have left it in, because I took this, and then I went back in the pipe to dplyr, and then I went back to data table, and then I made a ggplot2 out of it, which was absolutely horrendous. But given all my brain processing chapters, I thought, let's not even try to tell people that it works. If you really wanted to, you could, but I wouldn't do it. So when you talk about CPU, are there fast and slower solutions? Yes, there are. There are functions that run faster than others. And it depends on what you're doing, and that's why I started with context, because context is so important. If you're a beginner, sorry, I did see you. You can stick to just the packages that you know. Don't confuse yourself by adding other syntax, but it's definitely something you can do. Now, one of the things I do not like is people who point out speed and allocate it purely to functions and packages. How you are doing your code is about equally as important, if not more important. And I have a lot of examples, but I'm showing you the most obvious one, which is also the one that is very embarrassing to me when I look at it now, but it's not code, it's strategy. So I arrived at the bank, and I'm getting tables from the old databases. So there are the blue ones, they're the 8 gigabyte, and then there's one of 5. And then I'm getting a green one is the mapping table of the IDs, so I can link the IDs from people in the blue one. And then the yellow one is the new database where I'm getting weekly refresh. And so my first instinct, which is so silly, because these are all gigabyte CSVs except for the mapping table, is let's join them all. That was not smart. There is a group who made the soundtrack for this kind of behavior. It's Roxette. It did not work. I spent a lot of time waiting and retrying and restarting our sessions. And I had to do this weekly. It wasn't even of I'm going through the pain once and then I'm saving the CSV as a 20 gigabyte CSV probably, and then I'm going to try to import it again. I couldn't do that because these are weekly refreshes. Every week I have to go through this merger, which is not working. So there are actually strategies that you can do, and it depends. This is not a magic. You have to think about what you're doing. And I also couldn't do this the first week because I didn't know what was important yet. But how some of my code looked by January, for instance, is I'm starting from the old databases. In my case, I'm lucky there that that is static. That is no longer changing. And by now, and with going with the business experts through it, I can translate those whole tables, and we're talking about 200, 300 variables, to a much smaller table with flags. And I know for every people, all the different cases that we're in that compare, there's a lot of logic behind these. I can flag all those people as certain cases. And then we're trying to fix people, or trying to analyze them and get them into the new database. We're first making subsets, and I'm only doing my very first join. No, there are some joins there as well, but not too many actually. I'm only doing the join then, which before was the first thing I did, was joining all those tables together. And once I have that, I only take those people. I don't even do a join. I think I do more in operations now than I still do joins. Because the experts do like to see the CSV with all the people, but I've kind of educated them that that's maybe not necessary. And right now, I'm just giving them subsets of the different data. Sometimes I still join these two, just so that they can see what I'm doing and checking that I'm not making any mistakes. But I'm hardly joining at all anymore, and I'm definitely not joining the big tables. Right now, I've simplified this one even more, where these are not even tables with flags. These are nearly all vectors of ID strings, and so I can very easily go to the blue table and say, give me everyone where the ID is in this one and in that one, and so on. So how you do things is very important. There is a blog post I wanted to put on here of Emily Robinson, which is very good, because in a lot of detail, where she has something very similar. She did a lot of simulations of something, which took her, after 4 hours, she was about half done. And she had very similar. She asked on Twitter, and everyone told her, go to parallel processing and go to Spark. She optimized all her dplyr code. She didn't even go to data tables. She stayed with dplyr. But what she was doing, how she was querying from SQL, which variables you could actually drop, because we all have a habit of taking all the information with us, or at least too much. Drop the variables you're not going to need to go an awful lot faster. So how you think about your code is at least as important, and in some cases, I think even much more important, to speed up what you're doing. And I think there are much more examples. I shared one of mine. There is the one of Emily, but there is even much more out there. Now, in some cases, you will not get there. That's where, again, context is important. If you are doing simulations of something, then going parallel might be what you need to do. If you're working with data, that is even bigger, right? If you're connected to databases, then whatever I'm doing with my CSVs might not even work for you. I'm not going to talk about these. I'm also not an expert in many of these. I've tried some of them. I've not tried some of the others. But you can play with your infrastructure. If your speed is not solvable by being smarter and using functions that serve you well, you can go to virtual machines, you can go to servers, you can go to Spark, you can go to parallel processing. These things exist for a reason. There are a lot of special subject-oriented packages. Time series is optimized for those kind of things. And if you really want to be more adventurous, you can write your own functions in C or in RCPP. By accident, I yesterday saw a tweet from Mike passing by, I'm very curious, he's making functions that are called Wibble Wobble, and I forgot the third one. I have no clue what he's doing. So on the brain processing side of his function naming, I'm not there yet. But he did yesterday post how he wrote his first function in C++. It's called Wibble, and it's a lot faster than Tibble and base. So you could go that route, but I will definitely not be the one teaching you to do that. So I hope that was inspiring for you on the brain processing side on some of the benchmarks that I advise you to do. It's a very fun game, actually, and trying to guess which one is faster, and sometimes there are some big surprises waiting. And to think much more, especially on code that you're running through frequently. If you're running through something once or twice, it doesn't matter. But if, like me, every week you need to do all those merges, it's really worth thinking about how can I do something very differently and how will that help me. So I hope that was useful. If you have any questions, I will try to answer them.